Uh, Third time recording this first one, 9 minutes, second one, 7 minutes. Let's get this to 5. 4.25, f of x equals 2x squared minus 3. And then our range is 0 to 2. For this problem, we're going to be using the mean value theorem and the antiderivative equation. So first off, I input our f of x and our b and a values. So our a and b values into the mean value theorem, and so I end up getting integral 2 between 0 parentheses 2x squared minus 3 d of x. This is antiderivative d of x, not derivative d of x, and then equals 2c squared minus 3. 2c squared minus 3 is just f into c, so you're just inputting c for x into the f of x equation, and then it's just b minus 0, or b minus a right here, which is 2 minus 0. And then we distribute, so since the integral applies to 2x squared minus 3, we're going to want to separate those to make it easier for us to use the antiderivative equation. And then we just distribute the 2c squared minus 3 to the 2 minus 0 over there, and we end up getting 4c squared minus 6, which just brings down. I keep bringing it down for a while. And then so my next step is, now that we have the x values isolated, or the two different terms isolated, we now want to move the constants outside of the parentheses in order to make the antiderivative equation easier to use. And so when we move, so one thing that I gotta point out too is, when we take the derivative of something, we're taking away an x. When we do the antiderivative, we're going to be giving it an x. And so in that sense, whenever there's, if it's 3x to the, if it's just 3x and we take the derivative of it, we're going to just get 3. And the thing is, we're not getting 3 and a 0, we're getting a 3 and a 1, and the 1 comes from x to the 0, so there's still that x to the 0 there, it just turns to 1. And so what we have to remember is that whenever there's a constant without an x value, there's still an imaginary x value that equals to 1, and that's why we don't see it pop up. And so now what I'm doing is I'm moving the constants outside of the parentheses in front of the integrals, and I am isolating our x values. So we have x squared and x to the 0 right here, still bringing down the 4c squared minus 6. And then so our next step is to input our x squared and x to the 0 into the antiderivative equation. And all you have to know is that x, or the x value, and then whatever the exponent is going to be your a value. And so for x squared, it's x squared plus 1, x squared plus 1, the equation up here. I mean, I wrote it down right here. And then in the denominator, 2 plus 1, and then same for the second part, x to the 0 is just going to be x to the 0 plus 1, divided by 0 plus 1. And then, so this is what we end up getting. Still with the constants on the outside, we end up getting x cubed divided by 3 and x to the 1 divided by 1, still bringing down the 4c squared minus 6. So then what I do is I redistribute the integral to the two x terms, and so now we have integral 2 between 0 parentheses 2x cubed divided by 3 minus 3x to the 1 divided by 1 equals 4c squared minus 6. And so the reason I do that is because now we're going to take the integral of this new equation that we have right here. Sorry, I'm probably blocking it with my hand. And so we're going to be taking the integral of this new equation that we have right here. And so the next step right here is us taking the integral. So what I know for the integral is that you take the numbers, well, b and a, because this is a b and this is an a, and you keep them in the same position, b up top, a down below. And now we have to input this b and this a value into this entire equation separately, and then subtract them, and yeah. And then so I do that here. Sorry, I just was thinking that I forgot a step. And so I do that here. First I do it with the b value, because it's always b minus a. So first I do the b value, and then I do the a value. And so it's literally just 2 implemented into this entire equation for x, and then 0 implemented into this entire equation for x as well. And then still bringing over the 4c squared minus 6. Oh, I'm at 5 minutes. And then so just doing algebra here, you simplify down eventually until you get rid of the brackets, and then you just solve for c. So that's what I do right here. I start solving for c. I divide by 2 on both sides. The 2's simplify down to 1/3. Then I multiply by 3 on both sides. Then I have to distribute the 3 to this entire equation. So then it turns to 6c squared minus 9 equals -1. And I got the -1 because I multiplied by 3 on both sides, and it just resulted, or it simplified down to -1. And so we're going to bring this over here. Our -1 equals 6c squared minus 9, just adding 9 to both sides. And then you get 6c squared equals 8, divide by 6 on both sides. You can simplify 8 over 6 to 4 over 3, and then all you do is take the square root of both sides. And since we're trying to find a value that is in between this 0 and 2, we need to actually solve for c. And so that's what I did right here. I end up getting c equals 2 divided by square root 3. Square root 3 is like 1.73, and then I just divide 2 by 1.73, and then c equals 1.15, which is in between the points that we were given. So yes, it does work. Thank you. So problem 4.27, number 1, our given is x squared minus 3x with interval 0, 4. So for this problem, we're going to be using the average value theorem and the antiderivative equation. Just like 4.25, the average value theorem is very similar to the mean value theorem. The only difference is instead of having f into c b minus a over here, we now have 1 divided by b minus a in front, and that's about the only difference with the mean value theorem and the average value theorem. So my first step is I input our givens into our equation. And so that gives me g of x equals 1 divided by 4 minus 0. Our b is 4 and our a is 0. And then integral 4 between 0 parentheses x squared minus 3x. So our next step is going to be just like we did in 4.25, how the integral 4 between 0 applies to the x squared and the negative 3x. We're going to apply the integral to them separately. So then we could apply the antiderivative equation, which is easier when they're alone and separate. So we then get down to g of x equals 1 over 4, integral x squared minus 3 parentheses x, and like I did before in 4.25, I'm kind of limited on steps right here because my whiteboard is not as big. But like I did in 4.25 is I moved the constant over just so it's easier to input our values into the antiderivative equation. And since x squared has a 1 in front of it, there's an invisible 1 in front of between the 1 over 4 and the integral 4 between 0 right here. And then this -3 just gets moved over in front of the integral right here to -3 integral 4 between 0 parentheses x. And then our next step is to input the x squared and the x into our antiderivative equation, resulting in g of x equals 1 divided by 4, integral 4 between 0 parentheses x cubed divided by 3 minus 3, integral 4 between 0 parentheses x squared divided by 2. And so that's the result after you get our antiderivative, or after inputting our values into our antiderivative equation. Then we now redistribute that integral 4 between 0 back to the entire problem. And we then conjoin the two new x values that we got together as 1. So we end up getting g of x equals 1 divided by 4, integral 4 between 0, brackets, because it applies to all of them, the two new inputs we just got, the two new values, x cubed divided by 3 minus 3x squared divided by 2 is our new equation. And so just like we did in 4.25, when we get our new equation, we then input our integral b and a into the equation. So for this, we have 4 and 0, so our first step is going to be inputting 4 into all the x's into this equation, and then we're going to be doing the same with 0, and that's what we get here. This is the 0 portion, and this is the 4 portion. Just doing algebra, 4 times 4 times 4, 64 divided by 3 minus 24 divided by 2. So then you get a g of x equals 1 divided by 4, brackets 28 over 3. Oh my gosh. Minus 0 because the 0, our a term is 0, and so anything multiplied by 0 is 0. So we end up getting g of x equals 1 divided by 4, brackets 28 divided by 3, which is right here, and then we're going to bring that up top over here and finalize it. We're just solving for g of x at this point to see if our average point fits within the interval. So g of x equals 28 divided by 12. G of x equals 2.333. Infinite keeps going, and then 2.33 is in between our points 0, 4, and so it does work. And we use the average value theorem instead of the mean value theorem, and the ultimate difference is that we're just checking the validity of all these points rather than just one single point, which is what we do with the mean value theorem. And we also use the antiderivative equation again. We use the antiderivative equation in the average value theorem and the mean value theorem. And this is number 1. Okay. So for 4.27, number 2, it's just like number 1 for 4.27, and then it's also still similar to 4.25, except we're using the average value theorem instead of the mean value theorem. Once again, the only difference is the 1 divided by b over a instead of the f into c, parentheses b minus a. We're also going to be using the antiderivative equation again as well. Let me just grab my pen. So first off, we input our given values into the average value theorem, which is the step right here. So it's simply 1 over b minus a, 1 over 3 minus 0, integral 3 between 0, absolute bars, x minus 2 absolute bars, plus 3. 3 is not in the absolute bars. So I was a little bit confused on that step of whether or not you could just absolute bar this right away and it would just turn to x plus 5. But then I noticed that later in the problem we end up with an x plus 5 anyways when you do use the absolute bars down here in the step that I'll explain. And then the next step that I do is I isolate each individual constant and variable inside this entire equation, besides the 1/3 because that's outside of the integral. So then I end up getting 1 divided by 3 integral 3 between 0 parentheses x, integral 3 between 0 parentheses -2, integral 3 between 0 parentheses 3. That's right here. And so once again, what I'm doing there is I'm just isolating the terms so it's easier when I apply the antiderivative equation, because the next step is to move all the constants in front of the integrals. So the x doesn't have a constant, but remember the -2 and the 3 are the constants, but there's also an invisible x to the 0. We learned that in 4.25. There's an invisible x to the 0 for both of those since they're just constants. But also if I just added the 5 up there, it would just be 5 here and not -2, -3. But anyways, now that we have our constants isolated, now that we have our x terms isolated from our constants, we apply the antiderivative equation right here to the x to the 0 and the x to the 0, because remember we had 2 constants, so 2 invisible x to the 0s. So this next step is just writing out this antiderivative equation for all of those. This next step is just finalizing those, finalizing the numbers, and then this next step is me redistributing the constants back into the equation. So then you just get f of x equals 1 divided by 3, bracket integral 3 in between 0 parentheses x squared divided by 2, integral 3 between 0 parentheses -2x divided by 1, integral 3 between 0 parentheses 3x divided by 1. And so remember that these absolute bars are still around the -2 and the x, and so that's what this step is right here. The absolute bars, I don't know if you can see them right there and right there, kind of squeezed them in there. And so right here I realized that we end up getting a 5, which is the same thing if we just used it up top. If we just used the absolute bars up top, we would have already gotten the x5, but since we so the 5x, not the x5, but since we're using it down here after isolating all the terms, it just turns the -2x into a +2x right here. That's what this step is. And so then 2x plus 3x is just 5x, and that's what we get right here. And so now we then have our equation to begin our interval, or our integral process. And then so once again, we take out the integral and we apply it to the brackets. We have a 3 up top and a 0. Keep in mind the 3 is the b and the 0 is our a, and it's always b minus a. We have to input this 3 into all the x's into this equation, and then the 0 into all the x's into this equation separately, and then we're going to get 2 different equations and subtract each other. So then that's what we get right here. Keeping the 1/3 on the outside on the bracket, we get f of x, the b equation right here, and then the a equation. And since a is 0, we end up getting 0 for this one. And then you just do some algebra. You simplify the side that isn't 0, because you can't simplify the side with 0. And then you end up getting f of x equals 1 divided by 3 brackets 39 divided by 2. Excuse me. And then I just multiplied across 39 divided by 6. You get f of x equals 39 divided by 6 right here. And then 39 divided by 6 equals 6.5, which is not within the 0, 3 interval that we're given. So I believe that this does not work, but I also am a little bit question heavy on whether or not I am correct about this one. But yeah, that's 4.27 number 2. Thank you.